this video, we're going to take a look at finding the volume of a cylinder. So what I've got here is a sketch or a diagram of a cylinder which has a diameter of 8 centimeters and a height of 10 centimeters. Okay, we can see that here on our diagram. And what I want to do is just simply work out the volume of the cylinder, giving our answer in terms of pi. So we'll come to that in a moment where it says given the answer in terms of pi. First, let's just recall how we find the volume of a cylinder. Now what I've actually got here is a prism. So remember, the formula for finding the volume of a prism is the area of the cross section. So in this case, that would be the area of this circle on top or at the bottom, depending on which way you look at the diagram. And then we times it by the height. So the area of the cross section, well, this is a circle. So the area of that will be pi r squared. So the volume here is going to be pi r squared. So that's the area of the cross section. Then we times it by the height here. Okay, so times by the height. Now we've got everything we need here. So V for the volume is equal to pi times by the radius squared. So here what we've got is a diameter. So remember, if we want the radius, we need to divide this by 2. In that case, the radius here, r, is equal to 4 centimeters. That's going to be times by 4 squared. And then we times it by the height, which is 10. So in that case, 4 squared is 16. So V is equal to pi times by 16 times by 10. Now this is where we come on to the final part. It says giving your answer in terms of pi. What this means is pi should be involved in your final solution. So in other words, don't give your solution your volume as a decimal, keep that pi there. So if I do 16 times 10, that would give me 160. If we times that by pi, we get 160 pi. So therefore what we're saying is the volume of the cylinder is 160 pi. Okay. We're not going to put that into our calculator and get a decimal. We're going to leave it like that. Okay. And like you can see, the method and the process is actually quite straightforward. It's just being able to recall how we derive this formula here for the volume of a cylinder. So that's our solution to the first example. It's up to you now if you feel like you're confident enough to have a go at this. If you are, pause the video now, have a quick go. But if not, let's take a look together. So again, what I've got here is a cylinder which has a radius of 6 centimeters and a height of 12 centimeters. Now for this one, we want to work out the volume again, but this time we are going to give the answer to 1 decimal place. So in this example, we're not going to give the solution as a multiple of pi or anything like that. We're just going to put it into our calculator and see what we get out. So again, let's just recall the formula for the volume of a cylinder. So that's going to be the area of the cross section, so pi r squared, times by the height. Okay. We know what r is. R is 6. We know h is 12. We just put everything now into our formula. So V is equal to pi times by r squared. So that's going to be times by 6 squared. And then times that by 12. So at this point here now, all you need to do is put this here on the right hand side into your calculator. So V is equal to 6 squared, so that's 36, times by 12, and then times that by pi. So times that by pi. And we get quite a large volume here. So we get 1,357. So if we're doing this to 1 decimal place, I get 0.168026. So to 1 decimal place, that'll be 1357.2 there. Okay. And we're talking about volume, so be careful with your units here. So it's in terms of centimeters, and this will be centimeters cubed there. Okay, because it's volume. I think I missed that on the last one. We should really have 160 pi centimeters cubed there. Okay, so don't forget units. Really important that you don't forget that. Like you can see, I've made that mistake myself already. So make sure that you don't make that mistake as well. Okay, so that's our solution to the second question. Moving on to a slightly more complicated example now. What I've got here is a cylinder which has a radius of 6 centimeters and a height of h centimeters. We know the volume, that's 180 pi centimeters cubed here, and we just want to find the value of h. So again, let's just recall the formula for the volume of a cylinder. So that's the area of the cross section, so that's pi r squared, and then we times that by h. So we get pi r squared h. Now what we know here is we know r, that's 6. So we know the volume is 180 pi, so that's 180 pi is equal to pi, so that's pi, times by the radius squared. So if the radius is 6 here, times that by 6 squared. And then we times that by h, but we don't know what h is. Okay, so we just leave that as h. So where do we go from here? Well, we have a pi on both sides, so the first thing I can do is get rid of that by dividing pi on both sides. That'll disappear on the left-hand side, and it will go on the right-hand side as well. So what I've got now is, if I just make this side here on the right-hand side go over to the left, if that makes sense, I'm just going to write it the opposite way around. I've got 6 squared times by h is equal to 180. Okay, so the pi's have just disappeared off both sides. Well, 6 squared is 36, so I've got 36h here, so 36h, and that's equal to 180. Now finally, all we want here is the value of h. That's what we're asked to find. Okay, so in that case, I just need to simply divide both sides by 36. So h is equal to 180 divided by 36, and that will give me 5 there. Okay, so seeing as our radius here is in terms of centimeters, our height will also be in terms of centimeters there. Okay, so the height is 5 centimeters. Moving on to the very last question here, what I've got is a cylinder which has a radius of r meters and a height of 10 meters. Now again, we're given the volume of the cylinder, that's 490 pi meters cubed. We just want to find the value of the radius r. Now we don't have a sketch for this. It's completely up to you whether you do a sketch. It isn't necessary at all, and I'll just proceed without doing the sketch, mainly because I'm not very good at drawing, but it's completely up to you, like I said, if you want to include that diagram. Now we've got everything we need really for this, so we just need to put everything together. So again, we're looking at the volume, so let's just recall the formula, the volume of a cylinder. So that's pi r squared times by the height. Okay, so that's the formula for the volume of a cylinder. We don't know what r is, that's what we're looking to find, but we do have the volume, so that's 490 pi. That's 490 pi, and that's equal to pi times the radius squared, which we don't know, but we do know the height. The height is 10 meters, so we times that by 10. Now again, we have a pi on both sides, so we can start by dividing both sides by pi. So it'll disappear on the left-hand side and the right-hand side. So what I get now is 10r squared. So again, just flipping which way around we write these, I get 10r squared is equal to 490. Okay. We're looking to find the value of r, so we need to basically rearrange here and make r the subject. So I'm going to divide both sides straight away by 10. So if I divide 10r squared by 10, then we get r squared. And if I divide 490 by 10, that would give me 49. We get r squared is equal to 49. We just want the value of r, so all I need to do now is square root both sides. Now in that case, what we get here is the square root of 49, which hopefully you recognize is 7. Okay. Now obviously we can't include the negative solution here. This won't be equal to minus 7 because we're talking about a length. We're talking about the radius here. So it wouldn't make sense if we got a negative radius there. Okay. Now our height here was in terms of meters. So it would make sense that our radius is also in terms of meters. Okay. So the radius here is 7 meters, and that gives us our solution to the final question. And that actually brings us to the end of this video on finding the volume of a cylinder. In the next video, we're going to take a look at finding the surface area of a cylinder.